All right, how's it going today? So, questions? Too early for questions. All right, so I graded PA3, the HighLow, and that looked really good. So most people's games seem to play well. Got lots of talking cows. Had one game with a secret option, which was cool. So most of the deductions for PA3 fell into two categories. First category was simple. It was just not following the instructions correctly. So, allowing guesses of 0 instead of going from 1 to 100. Switching around the meaning of H and L. So saying that your number was too high versus your guess was too high. Or having to hit the enter key after you type H or L, things like that, okay, which you take off a few points for, but it doesn't worry me as far as being able to write the code. The other source of deductions was primarily edge cases. So most people's programs played the game basically well, right? If you think of the number 60, you can say high or low, and it'll come down and it'll guess 60. Efficiently. But what are some of the edge cases that you could test for in this game?
Anything that's not an H or L.
Anything that's not an H or an L. Okay, so bad HLC input. All right, what else? Okay. So cheating. How do we detect cheating? How do we test whether our code is responding to cheating correctly? Okay. So that's what's happening in the code. How would we exercise that as a user? I mean, you tested this, right? So you might think 60. Play till it guesses 60. And then don't tell if that's correct. And if it's narrowed it down, if 61 was too high and 59 was too low, and it says, is your number 60? And you say no, right? It should say, hey, something's wrong, right? Well, there's two ways you can say that it's not correct. You could say that that's high, and it should say, nope, that can't be right. And you could also say that that's low, and it should say, nope, that can't be right. And those are two separate cases, right? In some cases, saying high might cause it to throw out a message saying you're cheating, but saying low might trip it up, right? So you want to test both of those. What's another edge case? Yeah, you definitely want to try with command line inputs, which is a wider range. What about if you think of the number 100? So now every time it guesses a number, it's going to be low until it guesses 100. But it's got to get all the way up to 100 before you say correct, right? That's an edge case. In some cases, code would only go up to 98 or 99, then it would say you're cheating. Or it would go up to 99, and then it would guess 99 a second time, then it would say you're cheating, right? So lots of things you can catch by that. And same thing on the other end. Think of the number 1. And make sure that it guesses all the way down to 1 before it says, hey, I think you're cheating, right? And if you tell it 1's correct, it should say, okay, you got your number. And then Try cheating with those guesses. Let it get all the way up to 100 and then say, nope, 100's too high or 100's too low, and make sure that it says, hey, you must be cheating, right? So you've got your regular cheat, saying it's high, saying it's low. You can think of 101. You can think of 101, say it's high and then low, and then think of 1 and say it's high and it's low. There's 8 edge cases, right, that you can try in addition to thinking of a number and seeing if it actually guesses it. And then repeat all of that with a wider range, because maybe when you were writing this you were thinking 1 to 100 and you hardwired something, right? And when you play from 1 to 1,000, maybe that something doesn't work anymore. So now you got 16 edge cases you can work with, right? And playing high-low 16 times will only take you like 5 minutes, assuming you've been working with this code the whole time. You're really good at hitting H and L with your eyes closed, right? But it's worth doing it, right? Because that's kind of what I'm doing when I test your code. I'm trying to come up with all the different weird cases to make sure that you've handled all the possibilities. And like I say, that's part of the kind of art of programming is being able to do testing and then debugging, of course, if you find problems. So keep thinking about test cases, and particularly edges. All right, questions on the new ODP?
Are we sanitizing the input at all?
What input?
From the main file, are we assuming that it can be something other than a positive integer?
You're writing a function called put that receives an argument which is an integer, and that's all you know, is that it's an argument that's in an integer. But there's no restrictions on what the value of that integer might be. And even if the main program were to pass a character or a double or something like that, you're just going to see an integer, right? Because C doesn't really have a way of knowing that this was not an int. So yeah, you don't have to do any of that stuff. So does everybody understand what this is supposed to do, or is this the first time you've read this? Okay, so the idea here is you've got a pair of functions you're writing, put and get. Okay, and put lets you basically take an integer and stick it aside somewhere, and get just returns the value of whatever it was that you put. So if I say put 17, and then somewhere down the road I say get should return the value 17. Okay, so it's basically asking me to save a variable somewhere. So if I say put 5 and put 200 and put -6 and put 3, and then I say get, it should return the 3. Okay, whatever the last thing is that you put, that's what get returns. And if I call get 100 times, it's going to return 3 each of those times. Okay, there's nothing fancy going on here. There's no memory of past puts. Put just takes a number, saves it somewhere. When you say get, it says, oh, okay, here's the number that you put. So that's the goal of your functions. And the implementation is done using a global variable. So let's talk about variables. Okay, so is anybody weirded out by the notion of void?
Doesn't return anything.
Doesn't return anything, right? If we say int myfunc has to return an int. If we say character myfunc has to return a character. If I don't want my function to return anything, I can say the return type is void. And it's just a way of telling the compiler, I'm not going to return anything from this function. I'm not going to say blah equals myfunc, because myfunc doesn't return anything. And when I write the function, the type of the return argument, I'm just going to say void. And it's not returning a void thing, it's returning nothing. It's a little existential. So it's just saying no return value from this. All right, so we have a function which sets x equal to 100. We have a main program which sets x equal to 12, prints the value of x, calls my function, prints the value of x again. Right? So pretty straightforward. And when I run this, it prints out 12 both times, which should not surprise you. Because down here, when I said x equals 100, what x was being changed? Right, the x relative to this function, this one right here. Nothing to do with this x up here, which is equal to 12. So when I print x here, it prints 12. When I print x here, it's printing this x, which is still 12. Because down here, right, there was a different x. Now, if we get rid of that, we'll get a compile error saying, hey, in this function, x is undeclared. Now, if I declare x here, and I compile, it compiles fine, because now, when I say x equals 100, it refers to this x. But that's still different from the x that we set equal to 12. So what we're talking about here is scope. Okay, what is the scope of a variable? What's the range of my file within which this variable exists? So this integer x up here, its scope is between here and here. And anywhere between here and here, when I use x, it refers to this integer. This integer x is declared outside of a function. So its scope is basically everywhere from this point on down in my file. It's a global variable, okay, but it's global from this point on down. And if I declared an integer x inside here, if I did something like this, right, this copy of x has a scope from here to here. So when I say x equals 100, it's changing this. But if that's not in there and I say x equals 100, it's changing this. So now if I say integer x up here at the beginning, x is global throughout my whole file. But since I'm saying integer x inside main, there's a local copy of x from here to here. Right, and so it still does x equals 12. But if I get rid of this, now when I say x equals 12, since there's no x defined inside here, it looks for something that's scoped before this point in my file, and it finds this integer x. So x equals 12 refers to this, and down here x equals 100 refers to that same global variable. So now my variable changes inside my function. So that's a way that we can share information between different functions. But it's usually considered kind of sloppy. / maybe dangerous, right? The danger is having a global variable like this, especially a global variable named x, right? You really got to be careful anywhere in your code when you use the variable x to make sure you know what x you're talking about. Now, if you call it something like my global variable named x, right, you're not going to accidentally say, you know, integer x and step on that global. But it's still considered borderline sloppy, even though globals exist at the assembly language level all the time. But an advantage of this is that we can call this function and change the value of something and then get to that something in another function, right? And this is what you're going to basically do in your put get. So your put code right takes an argument so you're going to have some global integer. All you got to do in your put is copy the argument to that global variable, right, and return a 0. And your get just returns that global. So what's the action? When you call put, whatever argument you pass to it gets saved in this global variable. And then when you call get, just check the value of that global and return it. And this pretty much will either work or not work. There's not a whole lot of edge cases in here. Right? Try calling put a few times, call get a few times, mix them up, but it should pretty much either do what it's supposed to or it'll do nothing like what it's supposed to. But we'll build on this. So does that make sense what the behavior, the intended behavior is? So let's do something weird. All right, so we're going to develop some test code here just to play around, and this is a little sort of bonus stuff. So my main program is just going to call my function myfunc. And myfunc declares an integer x, and it's just going to print out the value of that variable x. Okay, so what do we expect this is going to print? And I don't want to call it putGet anyway. We'll call it haha. All right, so we run this and x is equal to some weird value, and we run it again, and that value changes sometimes. And that's not terribly startling because we haven't given x a value, right? So x is a local variable, and we never assign it a value, so its value is kind of randomish. And if I do this, it doesn't change anything because I'm giving x a value, but I'm giving it a value after I've already printed it. But if I call my function twice, the second time I call it, it's got that value of 12. even though x is a local variable, it seemed to remember the first time I assign it a value of 12, the second time I call it, it prints out that value of 12. And that's a little weird because I just told you that this is a local variable. Local variables disappear once you exit your function, but it didn't really disappear. Alright, so I'm going to make a new function called weirdness. Which also has a local variable which I'll set equal to 1,000. So what am I going to do? I'm going to call my func, I'm going to call weirdness, I'm going to call my func. And this is going to be weird. So what just happened? We called my func, it said x is an integer, it printed out the value of x, it's just random number, right? And then we set x equal to 12. And then we call weirdness, which is a different function which has a different variable called weirdvar, which we set equal to 1,000. And then we call my func, which has its x, and we print out the value of x, and hey, it's equal to 1,000, which is this value that we set in this totally different function, or this totally different variable. Right? So is that a little weird? So local variables are not initialized for you automatically. In some systems they are, but in this case they're not. But they're not random either. What's happening when you call a function with a local variable is you have your stack. Think Engineering 270 if you've done that. You have your stack, and when you call a function, right, you push your return address onto the stack. But then any local variables that you have also get stored on the stack, and it sets aside some space, and then it changes your stack pointer, and it's basically using part of your stack space to store locals. Okay, why does it do that? Because if you're the compiler and you say, okay, here's integer x, I'm going to store that at memory location 100, and here's integer weird, I'm going to store that at memory location 200. Well, you've decided memory location 100 is used for this variable x, and you can't use that location for anything else. And when you're outside of this function, you don't want the value of x anymore. You don't need it. You could reuse that memory location 100. But if you decide as a compiler, this is where I'm going to store x, it's going to go at location 100, you've allocated that location in memory for the whole duration of your program. And you're going to run out of memory possibly. So when you have local variables, the compiler sets them up to use space on your stack. And when you return from your function, your stack pointer gets reset to here, and all that space where you were storing those local variables is available for other things to use. The weirdness is that when you call the function weirdness, this is where it stored that local variable. When you call the function haha, this is also where it stores, or my func, this is also where it stores that function's local variable. It's the same location in memory. And because nothing else has come along and changed the value that was there before, you're picking up values from this other function that you called previously. So there's two things to note about this. One, it can look like it's doing something different from what it's doing. Right? In the first case, it looked like x was being treated as a global. Right? The other thing you should note here, though, is that there's a possible security issue here. Because this function, my func, over here, is actually printing out the value of a variable that was part of a different function and was supposed to be local to that function. So if weirdness is a function that's checking a password, right, and it's got some local variable that's got the correct password in it, and you're using that to compare the input to, and if you know that's what's going on, you can write a function that makes a local variable, doesn't initialize it, and it might have a default value that's equal to that password, for example. So memory management is fairly complex, right, the way all this stuff works. And it's one of these cases where knowing something about what's going on at the hardware level or the architecture level might actually come in handy. All right, so you don't need to understand all of that to do the ODP, but that's just kind of a freebie of some of what's going on. We could also print the addresses of these local variables and see this same behavior, right? X and weirdvar would both have the same address in memory. All right. Questions on PA4? PA4 will very possibly take you 2 weeks to do. So you really want to be started on it already, or today if you didn't already start it. If you don't start it till this coming weekend, you're probably going to run out of time, because it's just got lots of, I mean, you'll get something done, but it's got lots of bits and pieces, and you may find yourself going back and changing the way you're doing things more than once, right, as you develop further pieces of it. But it's a really good assignment to work through, right? Because it'll really help with sort of like big picture planning, how are all the pieces going to fit together, and then implementing those pieces and going back and adjusting. It's good practice for all of that. Anybody write their super duper get car yet? Cool. All right, questions on the pieces, how they hook together, modularization? Yeah.
For global variables, if the functions are in separate files, do those functions use that global?
That gets tricky, which is why in the ODP I said to put them in a single file. If you have a global that's in a separate file, then you need to use the keyword xturn and say xturn int x, and it'll tell the linker and the compiler that this x is global, but it's not within this file. And that gets you really, really into lots of possible hot water, right? Because it's just a lot easier then to sort of like get confused as to what's global, what's local. And it's pretty rare that you need global variables, right? Because we have a way to pass things from function to function. We can pass them as arguments, we can pass their address and then change the value and get it back from the caller. And generally that's going to be the more correct way to do that. And in PA4, because I told you the exact dimensions of your index and your phrases and so on, feel free to pass those just as arrays, right? I would avoid making them global. It's tempting because you just say global, you know, here's my array. But since they've got fixed dimensions, it's easy to just pass them and just declare, you know, dictionary is a character 1000 by 201, things like that. It won't take off if you do it global, but you might have a debugging session. So another thing I saw in some instances, this number sign exclamation mark bin bash has got to be the first line of your file. Okay, otherwise it doesn't do anything, it's just a comment. It's a special hook that bash use, or that the shell uses if it sees a script and this is the very first thing it finds in there. It treats it as, this is how I want to execute the contents of the script. If you have anything before that, right, that's no longer a shebang, it's just a comment. Doesn't cause any special treatment. So why does this matter? Well, if I run HighLow, right, it runs my HighLow program. But I'm sitting inside the bash shell. That's my usual shell. But you get a different user comes along and they're running a different shell, like the bourne shell, right? So if I do a PS, here's SH, that's the shell that I'm running. And if I say, let's run HighLow, it totally freaks out on me. Right? Why does it freak out? Because HighLow is a text file. It contains lines of text, and when you type in the name of a text file and it's executable, your shell starts reading those lines one by one and trying to execute them. And the bourne shell doesn't understand all this business with square brackets and equal sign, and stuff like that. It's got different syntax. And since I didn't have that number sign exclamation mark as the first line, the bourne shell's trying to ingest this code and it's just kind of going crazy. So if you make that the very first line, when I say this, the bourne shell will say, okay, I need to run a copy of bash and I need to feed these lines of text through bash and let it do whatever it wants to do, and so it plays your game correctly.
Would it do the same thing if you save the file as HighLow.bash?
Yeah, I think so. Right, so this is still just another file, and it's still going to freak out. By and large, file extensions are pretty much ignored. But there's things that understand them and treat them appropriately. But typically you call a shell script.sh or .bash or something, but it's not really used by anything. I don't know if that works. Yeah. So it's really got to be like the first characters. All right. Another advantage, let me get out of here. Another advantage of this is that you can put switches on here. And so bash has a switch-x, which is kind of like a verbose switch. It says, tell me what you're doing as you do it. And it may be useful for debugging. I don't actually find it that useful for debugging, mainly just because I don't really understand everything that it tells me. But in this case, I'm going to say bin/bash space -x. And now when I run HighLow, it gives me some feedback as it's executing statements from my script. So it tells me low is 1, high is 100. It's checking to see if space is different from space, which was looking for a command line argument. It's about to do an echo, and then it does the echo. It's echoed, hit any key, and now it's doing a read-n, and so on and so forth. So I can hit a key, and it tells me my guess. So this may help with debugging. I still find it usually more useful just to put a bunch of echo statements in. But if you've got a big mess and you really don't know what the heck's going on, sometimes first order, this will at least tell you kind of like where it is in your code. If you don't really know where to put your echo statements, this might help you pin it down a little bit. writing scripts is fine, it's fun, but it kind of takes a while. And you have to set the permission. Oh, by the way, I keep seeing people doing this. This whole business of change mode, right? You only have to do that one time. Okay, you don't have to type it every time that you change the file or you want to run the file. What it's doing is setting these bits that you can see over on the left that say basically this file is executable, right? I can edit that file, I can make whatever changes I want to it, and none of that is going to change the fact that it's executable, okay? But by default, when you create a file, it's not listed as executable. It's usually read-write only. So one time you have to change the mode to 755. But once you've done that, unless something else changes the mode, you don't have to worry about it. Now if I copy this, right, it actually copied the permission bits as well, so I don't need to change it on HL2 either. But if I make a new file, HL3, right, that's read only. And if I try to run HL3, it'll say permission denied. All right. So yeah, writing scripts works fine, but you can do a lot of scripting just on the command line. Okay, so let's say our if statements are confusing. We want to figure out how if statements work. I can do something like this: x equals hello, and I can echo $x and see it's equal to hello. And now I can say if bracket $x equals hello. Then, and I usually just do PWD because it's easy to type and I don't have to hit the shift key. Phi. And hey, x was equal to hello, and sure enough, it printed out my working directory. So now I think I know how if statements work. So I can set x equal to by, and I'm going to just up arrow to get back to that if statement. And it threw it all on one line, right? So we can use semicolons to put multiple statements on one line. And in this case, my if statement was there, and then the then and PWD came out on one line in phi. So I'm just going to execute that, and it didn't print my directory because hello is not equal to by. Right? So I can set x back to hello and go back there, and so let's do x equals 12. All right, so I can set x equal to 12, and if $x equals 12, it prints out my working directory. And what if I put this in quotes? That also works. And if I do this, that also works. But if I set x equal to 13, it also prints my working directory. What's up with that? So x is 13, I said if x is equal to 12, print my directory, and it printed my directory. There's a problem here. And I know exactly where the problem is. It's somewhere in that if statement, right? You want to discover this here as opposed to in the middle of a 100-line script. And the fact that your program isn't detecting cheating correctly or something, right? So when you're trying to figure out how to use these things, play around with them like in the simplest test cases possible, which may just be sitting on the command line. Put some variables together and explore. So why is 13 equal to 12? I offered an invisible $100 bill last class, but nobody claimed it, so still got it. Does this bother you?
Is it a free factor?
Most likely.
Is it because there's no space around that?
Isn't that annoying? Who knows? I think without the spaces, it's not seeing a condition, it's seeing a blob, and that blob is not empty, and so it evaluates as true. right? And that blob contains an equal and things on the left and right side, but it doesn't really care about that. So I don't understand why it thinks that that is true, but I understand that it's not doing what I wanted it to do, right? So, bless you. So you can find entire books on shell scripting in Bash, right? You could read hundreds of pages on this. I could lecture on this for like a whole week. And it's just data just being thrown at you or coming in through your eyes. It doesn't necessarily mean anything, right? But sitting down and typing in this line and seeing what it does will probably register in your brains differently from just reading, a few hundred web pages on Bash scripting, right? And so the point here is I want you to keep getting more and more comfortable with exploring, okay? Whether it's putting commands together or shell scripting or writing C code, right? Try to keep getting more comfortable with just like trying different things and trying to understand what's going on. Because that's really kind of the best tutor out there. It's really the best sort of way to discover things and have them somehow make sense to you. Way better than just listening to me talk about stuff. So don't fork bomb the server or anything, but within reason. Experiment, try things, see what stuff does. All right, so if bracket bracket dash E HighLow, then print working directory. If bracket bracket dash E HighLow blah blah blah, then print working directory doesn't print a working directory. So dash E is another kind of condition we can put inside Bash statements. It says, does this file exist? So this statement is saying if there's a file in the current directory named HighLow, then print out my current directory, which it does. But there's a file here that doesn't exist, so it didn't print anything out. But if I create that file, and then I execute that if statement, it says, yeah, that file exists. If dash X says if that file is executable. And that file is not executable because it's just a default 664. But if I make it executable, and then I say if that file is executable, print my directory, it prints my directory. So there are different things you can put here. You can say dash E to see if a file exists. You can say dash D to say is a directory. So when I say file, I really just mean the most general sense of file. You can say dash F for is it a file. So it's not a directory. Dash R says readable. Dash S says size is bigger than 0, so it's not empty. Dash W means it's writable. X is executable. And I think there's other options as well. but that's some of them. So why would you need to see if a file exists? Or if a file is empty? Say again? See if you could even use it in the first place. So, way back when, before things were networked, it was nice to be able to like chat with other people on a computer. And how do you pass information from one program to another if you don't have a network and you don't have sockets, which we'll talk about in spring, and all of this sort of networking infrastructure available? How can you write a program that lets you type a message and lets a friend see what you typed? And they're running a different program.
You're writing to a file that they can open.
Yeah, take your message, put it in a file, and they're running a program that basically checks that file to see if its size is bigger than 0, and if it's not, it sleeps for a few seconds and then it checks again. And as soon as it sees the size is bigger than 0, it can open up that file, read the contents, print it out, and then take a message from that user, put it into a second file. And the first user's waiting for the size of that second file to be positive. And you can kind of go back and forth like that. And after you read a message, right, zero out the file so that the next time you check, you know that there's nothing in there unless the person sending a message to you has put something in. And you can do file communication, right? And this was kind of how things like bulletin boards and chat programs and stuff worked in the 70s, because it works. It's actually how we drove some of our finance strategies in the 90s, because it worked. So, lots of reasons for using files. Reasons why you might want to know about these. All right. So keep working on PA4. Bring some questions tomorrow, okay, about whatever. And next few days, I want to basically start digging into more things like this. Some of the more things that we can do with Bash, different ways that we can do looping, ways that we can send signals to scripts and get information in and out of scripts and so on. I'm going to try to put together your midterm this afternoon, which means hopefully tonight I'll post a study guide and you can look at that, but it's basically going to be programming questions. So ODPs, programming assignments, things we've gone over in here is going to be a big bulk of the exam, and then maybe some stuff on regular expressions and putting commands together in Bash and pipes and GDB and this other stuff we've talked about. That'll be some piece of it. So I'll try to get together a list and post it, and we'll talk about it later this week. And your exam is on Friday, so you got a few days. All right, so I'll see you next time.